Okay guys, by this time you should have already recorded your variables notes in your notebook on page 8. Please make sure that that is the page that you recorded them on. They should have been colored to match so that everything that applies to the independent variable is in orange, everything that applies to the dependent variable is in blue, and everything that applies to controlled or constant variables are in green, and we have our questions down here in yellow. Okay, so we're going to be reviewing what all of these notes mean and giving you a little bit more explanation and context. Okay, so a variable is the things that could possibly change during a scientific experiment or investigation. And we've underlined the word possibly here because sometimes we change them among our test groups and sometimes we have to keep them the same. And it really just depends on what our investigation is trying to find out, what the question we're trying to answer is. And so to help you remember what variables are, you could remember that the word vary means to change. So you may have heard in commercials or at the bottom of the screen for something like Slim Fast, which is a weight loss drink. They will say at the bottom of the screen, results may vary, because the claim on the screen is this woman lost 50 pounds, but they want to let you know that that is maybe not a typical result. It can change from person to person. Okay, so there are 3 types of variables that you have in an investigation, in an experiment. Okay, and that is the independent or test variable, and this is just, these are synonyms. Sometimes your test calls it independent variables, and sometimes they call them test variables, and you will have to know them as both. Okay, then you have your dependent variable, also known as your outcome variable. Okay, and again, you are going to hear it called dependent, you're going to hear it called outcome variable, and you need to know it as both. So your dependent variable depends on the changes you make in your independent variable. So the value of the dependent variable depends on the value you changed in the independent variable. Okay, and then finally you have your controlled or constant variables. And those are can be called controlled, can be called constant. Okay, and you have to know them as both, but they're the same thing. Okay, so let's talk about what they are and what they mean. So the independent or test variable is what is being tested in your experiment. So you're looking at your testable question, you've made your hypothesis, and that is what you are changing in your experiment from test group to test group. Okay, and I'll clarify that a little later. Your dependent variable is what you are really measuring, what result, what outcome you are measuring to see the effect of the change you made in the independent variable. So you could really think of this as a cause and effect relationship. So your independent variable is your cause, and your dependent variable is your effect. It's hard to write with this thing, sorry guys. Okay, and then finally you have your constant or controlled variables, and these are the things you're going to keep the same among your test groups to make sure that the changes you see in the outcome or dependent variable were caused only by the changes that you made in your independent or test variable. And there's not some hidden reason you're seeing a change in your outcome variable. Okay, so you could also think of this as a battle scenario. Okay, if every experiment was a battle, your independent variable is who is competing, right? This is your versus. Okay, who is competing with who? Who versus who versus who? So if this was people who were racing, this would be your racers, right? You're comparing racer A to racer B to racer C. Okay, your dependent variable, your outcome variable, is what you are measuring to know who won the competition. So in a race scenario, you could measure who got to the finish line first. You could measure the time it took them to run a mile. It depends on how you are determining who won, and that could be different depending on who you ask, right? Or the outcome should be the same, but how you measure that outcome, you could measure it maybe a couple different ways, and that just depends on how you design your experiment. And then finally, you have your controlled variables, which is how do you make it a fair fight? How do you make sure that who won fairly? Okay, so these guys over here competing, if everybody starts, let's say, here's my race, they start here, and I've got guy 1 and guy 2 and guy 3 here. These guys are competing, and this is the starting line, but what if I let guy 4 start up here? And then guy 4 won. Okay, guy 4 got here first, and he's the winner. First place, number 4. Would that be fair? It would not be fair, right? Because he would have had a hidden advantage. He didn't start at the same place as these guys did, okay? And that would mean that we left a variable uncontrolled, okay? We let him have this hidden advantage, and it made it easier for him to win. And in science, we're not trying to get number 4 to win, right? We don't want to skew results to get the guy that we like to win. We want an accurate, reliable outcome so that we know in the future, yeah, this really is the best option, or this really is the one who is going to be get to the finish line the fastest over time, or this really is going to be the laundry detergent that is going to clean my laundry the best every time. You know, it just depends on which scenario you're talking about. Okay, so I'm going to scroll down. So that's the explanation of what the variables mean. And now we're going to go through some examples. All right, so at the beginning of an experiment, you have a testable question that you are trying to find the answer to. So in this first question, our question is, which brand of laundry detergent cleans the best? So if we are trying to figure out our versus, who is competing against who? In this scenario, brands of laundry detergent are competing against each other. So that would be our versus, right? So versus. How are we going to determine who won the laundry detergent competition? And you are going to define that in whatever way you decide that cleans best means, what cleans best means to you. But we're going to be looking for essentially clean clothes. Okay, and you could be saying which one has the least amount of stains, which one is the brightest white, things like that. How you measure that is kind of up to you, but we're looking for how clean the clothes are, right? That's the outcome we're looking for. How are we going to make sure that this is a fair fight between the laundry detergent brands? Well, when you do your experiment, you should be using the same amount of clothes. Right? You shouldn't use a bunch of clothes for Tide and only a couple clothes for OxiClean, a couple shirts for OxiClean, okay? You should be using the recommended amount by the bottle, right? The amount of laundry detergent you use. If you're using the recommended amount of Tide, you shouldn't be using double the recommended amount of OxiClean. Okay, because then it's not fair, right? OxiClean has a hidden advantage. And then you should be using the same washing machine, right? Because if I wash it in my washing machine with Tide and you wash it in your washing machine with OxiClean, maybe your washing machine is a better quality washing machine. Maybe it's not the laundry detergent that made the clothes cleaner, but the washing machine that made the clothes cleaner. So if you're comparing the laundry detergents, you should only be comparing those things. You shouldn't be adding extra variables in there like different washing machines, different water temperature. All of those things should remain the same so that we know that the only reason we see a difference in how clean the clothes are is because of that brand of laundry detergent in that test group. Okay, so now let's go and do one more. Does warm water or cold water dissolve salt faster? So in this competition, who is competing? Who versus who? Well, you should be able to tell that it's warm water versus cold water, right? So that is who is in our race. That's in our battle. Okay, and what are we going to be measuring to see which dissolves salt faster, cold water or warm water? Well, salt dissolves salt faster. You are going to be measuring how long it took the salt to dissolve. So you're going to be measuring the time here. Okay, then what should you keep the same among your test groups, the warm water group and the cold water group, to make sure that the only reason that the salt dissolved faster is because of the temperature of the water and not because of some hidden reason? Well, you should keep the type of salt you use the same. You shouldn't use sea salt in cold water and kosher salt in warm water, because that's not the same thing. You should be using the same amount of water. It would not be fair for you to use a huge 2 liter of cold water and then a little cup of warm water, okay? Because that's not fair. It's maybe easier to dissolve salt in more water. And then the amount of salt should be the same, right? You shouldn't be using lots of salt in the warm water test group and then just a little bit of salt in the cold water test group, right? Because if you're just using a little bit of salt in the cold water, less salt is probably easier to dissolve. You would have to do some background research, find out what you know about cold water versus warm water, but you need to keep those the same because that's the test there, okay? All right, we'll talk more about this, but hopefully you guys have a little bit better understanding of these variables, and we'll do some practice problems with some new testable questions. Okay, good job.